All right, example 2, solve x plus 2/5 squared equals 3. And again, this is a different structure than the last problem. And if we consider that p squared equals q is the structure that's required to use this difference of two squares theorem, it doesn't tell you what p has to look like. All this is saying is any object squared equals any number is allowed to use it. So this right here is p, this being squared. All right, so get that in your minds there, that's what's being squared. So according to the difference of two squares theorem, we know that p not squared is equal to the square root of q, and p is equal to negative square root of q. That's what the difference of two squares theorem tells us. So if x plus 2/5 is p, it's squared here, now it's not squared anymore. The theorem says if I don't square p anymore, I'm supposed to take the square root of q and the negative square root of q, so plus or minus the square root of 3. Is that simply applying the theorem? What that accomplished is that now instead of having x in a parentheses squared, so this officially is x squared here, now I've got x to the first power. All I've got to do to solve x to the first power is move the 2/5 over to the other side. Now when there's a plus minus present in your expression, put any numerical values in front of the plus minus when you move them. So the negative 2/5 goes right here, then plus or minus the square root of 3. Always put plus or minus whatever last in your expression. That's the best place for it to be. Alright, so move that 2/5 over and make it negative because it's positive. You change signs when you change sides. That is a very frequently missed thing by people. I don't know if it's a lot of stuff going on in the problems, they just completely forget all their other basic algebra stuff. But anytime you move something across the equal sign, its sign changes. I've seen that missed a whole lot. People just put 2/5 there instead of negative 2/5. So be careful of that. And again, that's as far as I can go. The square root of 3, I have no idea what the square root of 3 is to 15,000 decimal places, so I'm going to leave it as the square root of 3. All right, and that's fine.